Hi students, let's look at this question here, which was taken from the year 2011, paper 1 question 3 of the A-level H2 mathematics question. So this question is on parametric equations. So the parametric equations of the curve are x equals to t squared and y equals to 2 over t. Great, then after which we are told that the find the equation of tangent to the curve at this point, simplifying our answer. I think that's pretty okay. The first part, what we need to find is dy dx. If the point at point p squared over 2p, the parameter it is actually p, right? T equals to p, so this is actually t equals to p. This is important. Alright, so this is when t equals to p, you get this point here. You want to find the equation of tangent, what we need is dy dx. So x is equals to t squared, so we're going to find dx dt. This will be 2t. After which y will just be 2 over t squared, t. So this will be dy dt, which is actually negative 2 over t squared. Alright, that's pretty okay. So to find dy dx, you just need dy dt over dx dt. So we're going to put this as dy dt over dx dt. Alright, this will just be negative 2 over t squared over 2t. That will be negative 1 over t cubed. Alright, great. So once we are done, we could actually find the so dy dx, which is the gradient t equals to p, this will just be 1 over p cubed. Alright, so the equation of tangent, so hence equation of tangent, okay, I'm gonna just use y1 minus y2 equals to m, x1 minus x2. That's pretty okay. So where x1, x2 is this point here. So y1, so y minus 2 over p, and m is negative 1 over p cubed, x minus 2 p squared. Alright, so that's how we do this part here. After which we're gonna get the equation, here what we're going to do is just multiply this in, so it's 1 over p cubed x plus 1 over p plus 2 over p, this is y, so y equals to minus 1 over p cubed x plus 3 over p. So this is the equation of tangent in terms of p. Alright, so let's see how we can visualize this. So from the different p value, you will get different point on the curve, but if you're gonna put this equation of tangent in, it will just be the equation of the tangent along this curve here. Alright, so that's how we understand the formation of this this equation here. Let's look at the subsequent part. So for part 2, hence the coordinates of Q and R where the tangent meets the x-axis and the y-axis. So it's just the equation of line here. So Q is meeting, find Q. Okay, so if you look at this tangent here, so they're asking for where the this will be Q, where the tangent here cuts the x-axis here, and this is our this is Q, and that will be our R, right? This is our R. So regardless, so we could actually solve it in terms of P. Just remember, parametric equation, we could just solve most of the things with P, okay? So to find Q is when this case here, to find Q, we want it in x-axis, so this case here will be where tangent makes axis y equals to 0. So this case here, just replace this in 0. What we get is 0 equals to negative 1 over p cubed. So this will be 3 over p x equals to 3p squared. Okay, so hence Q is actually 3p squared comma 0. So to find R, that is when x equals to 0. So just sub x equals to 0 inside this expression here. Y will be equals to 3 over p. So hence R will just be 0 comma 3 over p. Okay, so these are the 2 points here. Let's see for the third part. So for the third part, find the equation of locus of the curve by the midpoint, traced by the midpoint QR as p varies. So we know that this tangent here, I'm not sure how it looks like, but like if we were to use, this is a tangent, not okay, this tangent here, this is q and this is r. With different p, what you get is so this is q over here, this is r, this would be 0, r is actually 0, 3 over p, and q would just be 3p squared. Just erase this, q 3p squared comma 0. Okay, so what we need to do here is essentially find the midpoint. The midpoint here, okay, will just be midpoint. The formula will be x1 plus x2 divided by 2 comma y1 plus y2 divided by 2, right? So in this case here, you just use in terms of p here. So the midpoint here will be 0 plus 3p squared divided by 2 comma 3 over p plus 0 divided by 2. So this will just give us 3 over 2p squared and 3 over 2p. Okay, so x, this parametric equation here, 3 over 2p, this is x, right? And y will just be 3 over 2p. So if you want to change this to in terms of Cartesian, we need to get rid of the p. So from here, make p the subject, so it's 3 over 2y. This is something which we have done quite often in our classes, right? So you just make p disappear. So one of the easiest way is just to make p the subject. So this p here is the easiest. As you could see that this p is a lone ranger here. So you just let p be this expression here. So p 3 over 2 is sub 1 into 2. Okay, there'll be x equals to 3 over 2, 3 over 2y squared. So key in calculator, you will get 3 over 2, 3 over 2, bracket 3 over 2 square. Okay, then this will be 27 over 8. X equals to 27 over 8 y squared. So this is a Cartesian equation. So what does this mean? It means that if you were to plot this equation in, so let me show you. Do they want it in terms of y? So this is a Cartesian equation. Okay, so if we were to plot this in, 27 over 8x, 8y squared. Okay. It will be the tangent, it will be essentially the midpoint where they meet. Alright, so let me show you. So as you can see, this is a parametric equation here. This tangent equation, this is the point here as p varies, and that will give us the equation of this tangent here. So if I were to switch this off, I'm going to find the midpoint of this point here and this one. Of course, this point will not be the midpoint, right? The midpoint is actually here. So if you think about it, is x1 plus x2 divided by 2, which will give us a midpoint there. Then y1 plus y2 divided by 2. So as we vary, this will be our midpoint, okay, between the two intercepts here. Now what it does with our Cartesian equation is when we plot it out, this equation here, it would actually, you look at the point, it will just follow, it will follow this curve here. Alright, so that's how we actually understand the equation that we're dealing with. So if any question or comments, please do let us know. Keep practicing and I'll see you in the next question.